Morning everyone, and welcome to our physics and astronomy session as part of our main event. My name is Sarah and I work here at the University of Leicester as part of the Future Students Office, and I'm going to be here gathering all of your questions throughout this session. So please do pop questions into the chat as we are going along, and we will publish those so that you're able to like and sort of comment on each other's questions. But in the meantime, I'm going to pass over to Dr. Susie Imber, who's going to run our session for today.
All right. Hi, everyone. Hopefully you can see me and hear me. My name is Susie Imber. I'm an Associate Professor of Space Physics at the university. My area of expertise is understanding the interaction of the Sun with the planets in our solar system, and particularly the Earth and Mercury, which I'm going to talk about in a moment. I'm also the admissions tutor, though, for physics. So if you have questions you want to ask me about the admissions procedure or the department or anything about the university, just drop them in the chat. And we'll cover them at the end. Okay, so in this talk, I'm going to kind of introduce you to the university, and then I want to talk a lot more about our department and you know, why you should study physics with us and what we have to offer. So, why Leicester? First question. Well, sort of university level introduction. We're actually one of the top 25 universities in the UK. According to the Times Higher Education Rankings. We are also really affordable city to live in. So I know a lot of students are worrying about these things, and rightly so. We're the third most affordable city, with lots of lovely student accommodation really close to campus that's relatively cheap. We have really good employability statistics. 94% of our students are employed 6 months after they finish, which is a number we're really proud of. And we're working hard on our sustainability agenda. Finally, we also have an excellent students' union, and I know that there are presentations about the union that you'll have a chance to listen to today. So what are we looking for in our students? We are looking for students who have empathy, care for others, treat people with respect. We're looking for students who have resilience, but also in physics especially, we're looking for students who have skills with problem solving. So students who have an interest in the world around them and the skills and the interest to kind of dig deeper and try and find out how the world works. That's what physics is all about. In terms of our department at the university, we actually are in the top 10 physics departments in the country, according to the Guardian Subject League Table, which just came out a couple of weeks ago. And so we're a really high-ranking physics department, both teaching and research intensive, and I'll talk a bit about both of those as we go through. Also, though, there's something called the National Student Survey, which I don't know if you've heard of yet, but it's a survey done by all third and fourth years as graduating students, so third years who are doing a BSc, fourth years who are doing an integrated master's. And at the end of their studies with us and all universities, students fill in this survey, 27 questions, and it's really to find out how their experience was. Did they enjoy their time? Did they feel that their studies were fruitful? We actually scored in the top 5 for physics departments in the country. Our student satisfaction number is 96%, which is absolutely enormous, and we're super proud of that. And really, the key to this is that our department is really friendly and welcoming, and that's the reason I work in our department. I really enjoy the kind of atmosphere, and I'm sorry that you can't visit the department and see that for yourself right now, but maybe there'll be opportunities later in the year. The other thing, I guess, about the National Student Survey, there's this question called, my course has provided me with opportunities to explore new concepts and ideas. We actually scored top in the UK for that. So our students are really happy with the way the course works and the opportunities they have to explore physics more deeply. I also kind of wanted to just highlight we're a medium-sized department here, which sounds like a slightly strange thing to say, like, why am I telling you they're a medium-sized department? But actually, I think at this point you're looking at different universities, departments, trying to work out what's going to work for you. The size of the department, I think, is one of the most important factors, and I didn't know that when I was applying for universities, and that's why I'm highlighting it to you. So thinking about kind of different departments across the country for physics, there are around 40 departments that offer physics, and some of them are very small. They will take about a few tens of students. Some of them are massive and they'll take hundreds of students. And we sit somewhere kind of comfortably in the middle. We take around 100 to 120 students into our first year. And this is important for you because actually it's a really personal decision for you to think about. You know, do I want to be in a department which has 20 or 30 students? You know, there's some advantages there in terms of the fact that you're in a small class, that might be advantageous. Disadvantages might be that perhaps there aren't many staff in the department, so not a broad range of subject areas or expertise. The other option is to go to a massive department. There'll be lots of members of staff there. You'll be in a class with hundreds of students. And it's really just a personal decision for you as to which of those sort of scenarios are going to work better for you. As I said, I think we sit somewhere comfortably in the middle. We have about 100, 120 students. We have around 45 members of staff. So that means that in a given year, there'll be 2 of you to every 1 of us. And that staff-student ratio really enables us to give you lots of attention and small group teaching and really helps the department feel friendly and welcoming. So that's kind of an introduction to why you might want to study physics with us and what our department's all about. I'm going to tell you a bit about our school now. We have a really strong heritage. We have the longest running Physics with Astrophysics degree course. And as I mentioned earlier, we have both research and teaching streams. So you will find institutions that are teaching only. You'll find some that are research only. They won't be universities, they'll be research institutions. We have a strong research and teaching program. And actually that's pretty important, I think, because the research that I'm doing in understanding the interaction of the sun with the planet, or space weather is the name of the research area that I study, that really informs the way that I teach. You know, I love my subject, and, you know, I can teach with a world of enthusiasm and obviously cutting edge knowledge on these subjects. So having a strong research portfolio, I think, is actually really important for the student experience. And we bring in about £40 million a year in research income. I guess the other thing to think about, though, is that our research income helps us to have access to facilities that then are opened up to our students as well. So, for example, we have 3 supercomputers at the university. The main supercomputer, her name is Alice. She lives in the physics department, and this supercomputer is part of a consortium of 5 institutions. So we all have supercomputers that are linked together. And the reason that we've been chosen as the hub for our supercomputer is that we have a massive astrophysics research program, and they do things like simulate galaxies colliding, for example. Like, imagine the kind of computational power you need to simulate 2 galaxies colliding together. And so this astrophysics research program has enabled us to have the supercomputer, and in turn, we give all of our students an account on the supercomputer. No one's broken it yet. That's not a challenge to any of you coders out there. But that means that you get the opportunity to learn how to code, if you're interested, on a supercomputer. And those are exactly the kind of skills you need if you want to go into a career in big data, for example, data analysis or science. Those are the skills that you're going to need to develop. And it gives you a great head start to have the opportunity to begin at undergraduate level and things like that. So the research grants really help support the student experience. For those of you that have been sort of looking around at different physics departments, I'm sure you've already started this process. There's something called the Institute of Physics, which you've probably come across. And this is like our governing body. So they accredit institutions based on the teaching and the degree courses that are offered. Not all institutions are accredited by the Institute of Physics. And to do this, you have to teach kind of the core of physics in a high quality way. And that means things like electromagnetism, quantum physics, thermodynamics, relativity, all the things you would expect to find in a physics degree have to be taught. And they assess us on the way in which we teach these subjects. And if we teach them adequately, or well, in fact, then we get accredited. And so we are an accredited degree course, and it's something for you just to look out for as you go to different institutions and have a look at their offers. We also win awards for our teaching quality. Every year we win awards for our teaching quality because our lecturers do courses on how to teach. You know, we all have teaching qualifications. We're all really passionate about our subjects, and it really comes across when we teach. So we win at least 2, if not 3, teaching awards every single year. So I want to kind of give you a bit of a history of some of the things that I think are important about our department that you might want to get involved in. We have a really strong history in space science and astrophysics. So space science is my area of expertise. For those of you that are kind of wondering what the difference is, space science, this is looking at things that in our solar system, bodies in our solar system. So it could be planets, it could be moons, it could be the asteroid belt, it could be our star. But it's really kind of designed around the idea that if there's a question I need to answer, I can send something to go and have a look and find me the answer. So that's kind of space science. Whereas astrophysics, that covers sort of the much broader area of stars more generally, planets more generally, and other star systems, galaxies, etc. So that's kind of the difference between space science and astrophysics. You can see some pictures kind of scrolling around here on the screen. BepiColombo, that one at the bottom there, that's the mission that I work on. It's a European Space Agency mission, and it's going to the planet Mercury. It's en route now. It launched in 2018, and I was lucky enough to go and watch it launch from South America, French Guiana, at ESA Spaceport. And we built one of the instruments on board. So there's 11 instruments on board. One of them was built right here at Leicester, and it's going to arrive at Mercury in 2025. So that's the mission I'm involved with. But you can see as these pictures scroll through, there really are no missions from ESA or NASA that we don't have some involvement in our department. And so we're just so thoroughly embedded in the space industry. And that gives the students great opportunities too. So one of the ones I want to highlight just to begin with is the Space Park. And I'm not sure how much you will have heard about that, but it's being developed, it's actually being built at the moment by the University of Leicester in collaboration with the City Council, the East Midlands Partnership and the government. And the idea is that it's going to be a centre for space science research and the space industry. So we're calling it kind of the heart of the space industry. And basically, it's a massive space park where businesses locate who are interested in the space industry or data products associated with the space industry. And they co-locate with the university. And we offer facilities, specialist clean room facilities, for example, we might collaborate on. And they bring expertise and industrial links. And so it's going to be a fantastic opportunity, not just for us doing our research, but also for our students, because as you start to go through your degree and you're thinking about working with industry, maybe you're doing a year in industry, maybe you're looking for placements in order to get a job when you graduate, having the entire space industry on your doorstep in your city that you can go and collaborate with throughout your university undergraduate career and then look for a job when you finish is going to be a huge advantage. And there's a few of the companies that we know are in discussion at moving to the space park at the bottom there. We expect the first phase to open in 2021. So this is an exciting project, and there'll be 3 phases in total. By the time we get to the final phase, we're going to have basically a factory designing and building spacecraft that we're going to be launched into space. So watch out for kind of advances in that area. Okay, so please feel free to ask me questions about the space park, by the way, at the end. I'm very happy to answer anything that you have. I wanted to show you some of our courses and what we have to offer. We have, sorry, a cup of tea. We have physics, BSc and masters, integrated masters, so 3 years and 4-year courses. Straight physics, physics with astrophysics and physics with space science. We also have physics with a foundation year. So this is a 3-year +1, so it's a 4-year degree in total. And you can do a year in industry and you can do a year abroad with any of those options. So year in industry and year abroad, they're done in the 3rd year. We have currently 4 places you can go for a year abroad. You could go to Australia, Canada, the Netherlands or South Africa. And we have students going every year to those places who just come back, you know, having had this amazing experience of learning abroad and in a different environment. So again, please ask me questions if you're interested in the year abroad. Year in industry, again, that's a 3rd year option. You can find your own placement if you want to. If there's something that you really want to do, you can contact a company and we'll support you in that. Or of course, we have links with industry already and we can support you with your applications. So those are the courses. Typically our offer, except for the foundation year, is ABB or 30 points with the IB. What I should also say, though, is that it could be that right now you love astronomy, and as you go through the degree, you realise your real love is space science. That's what I hope, anyway. It's my job is to convert you all to space scientists. So actually, our courses are super flexible. You might start out on your UCAS form, beginning with physics and astrophysics. And then as you go through, you choose your options, and your options may sort of change your path slightly. And we don't make you stick to doing astrophysics all the way through or stick to doing space physics if that's what you signed up for. It's a very flexible course. And the same goes for the BSc and the Masters. You can change your mind as you go through up until the beginning of 3rd year. So if you sign up, this is commonly the switch normally happens. People sign up for the 3-year and then decide to stay for the 4th year. At the beginning of the 3rd year, if you're on a 2-1 or above, and you had signed up for the BSc, you can flip to the master's course anytime up to the beginning of third year. Of course, third year is when the two courses start going in different directions, because 1 year is final year and the other has 2 years left. So you have to decide by then. And we insist on a 2-1 or above at that point, simply because the fourth year is really hard. You're doing super high level physics courses, and we want to make sure that you're ready and able to cope with that. But other than that, our course is really flexible. As I said, first bullet point, exactly what I was just talking about. You can choose options, and I'll give you some of our options in a moment to suit your interests and your career aspirations. In terms of our style of learning, as I mentioned earlier, we have a really great staff-student ratio, and that means that we're able to offer a really supportive learning environment. So we have small group tutorials at the beginning of your time with us. You're put in a group of somewhere around 4 or 5 students with an academic and personal tutor, and that person is there to look out for you throughout your degree course. They also meet with you weekly in first year and bi-weekly in second year, and in third year and fourth year actually. And they're there to support your core learning. So that core of physics that the Institute of Physics decrees needs to be taught in the physics course, that those things that all students study together, that learning is supported by your tutor. And they're just there for you if you need them. You can just go knock on their door if you need help at any point. The second bullet point here, the open door policy, is what the students love most about our department. And really what that means is that as you go through your degree or your courses, you're taught by different members of staff. So for example, I'll teach you in second year electromagnetism, and third year and probably fourth year. And as I teach, as we go through, there might be something that I say that you need some clarification on, or a problem that I've set that you're struggling with. There's 2 ways in which I can deal with that. I can set you office hours in theory, which means I could choose 4 until 5 on a Friday afternoon. Or we can have an open door policy. And we went for the open door policy because if you're struggling on a Monday, you don't want to wait until Friday before you can come and find me and ask a question. And you don't have to, because with our open door policy, I'll be in my office and my door will be open between about 9 and 6. And that means that if you need something, if you need help, if you just need a pointer in the right direction, you can always come and knock on my door, and and we can chat through whatever it might be. And that means you can come and find me on the Monday, and we can be all set, rather than waiting until Friday to come and sort any issues you might have. So the open door policy is just a really lovely way of supporting the students. We also teach in quite an interesting way. We do lots of problem sessions and workshops, because physics is a really active course. It's not really about sitting and listening to me for an hour. It's about trying problems and working through solutions. And so typically in a lecture course, you'll have a couple of lectures, and then a massive workshop where we go into a huge open plan room. We all sit down at tables, you sit down with your friends, and I set you some problems, and you'll go through those problems in groups. I'm not assessing how well you're doing. And if you get stuck, you just put your hand up, and I'll come and I won't tell you the answer. I'll nudge you in the right direction. And this is the way that you learn physics. You learn by talking through problems with others, and you learn by solving problems yourself. And then we'll do a few more lectures, and then we'll do more workshops. And this is kind of how we teach you physics as you go through. And actually, it's really important in terms of the depth of learning that the students get, because listening to me with the best will in the world, you're not taking in every word I'm saying. And you won't know that you aren't taking it in until you come to revise for your exams and you realise, oh my goodness, I had no idea what Dr. Imber was talking about. Really, the workshops are much better, because by doing problems, you get much deeper learning. And it also means if there's something you haven't understood, you haven't understood it. At that point, you can come and ask for help, rather than waiting until the summer and then kind of panicking over revision. So workshops and problem sessions are a really helpful way of working through and learning well. We do lab, of course, in first and second year. There is compulsory laboratory for everybody. We have 2 huge computer suites available for students to use anytime, and we teach programming courses as well. You can choose from a variety of programming languages to learn, and you can do advanced programming if you're interested. If you want to, you can do your final year project on some computational astrophysics problem on the supercomputer if that's what you really want. We have lots of private study areas. We have private study areas in our foyer. We have about 8 small rooms that you can book in the physics department. They seat about 12 people. Any student can book them if they want to, just a place to have a bit of quiet time, do a bit of study, or collaborate with colleagues if you're doing a group project. And textbooks, I meant to sort of mention textbooks. We give you all the textbooks you need in first year. So I'll be there, actually next week I'll be there handing out textbooks to the students as they start this year. We give you a big copy of something called Tipler, which is our huge university physics textbook. It's about 1,000 pages. You'll take it home and you'll leave it there. Don't drag it into the university backwards and forwards. And we also give you copies of the maths books that support our course, and they were written by us, so they perfectly support the physics that you'll be learning. After that, there may be core textbooks that are recommended as you go through different courses. You don't have to buy any of them. The library has subscriptions to them. The one, for example, in my electromagnetism course, there are 100 copies in the library. So there's enough copies for every student to have a textbook at any point. So you don't have to buy huge bookshelves worth of physics textbooks if you don't want to. But probably as you go through and find things you're really interested in, there'll be books that you'll choose to buy and use. As I said, we have a pretty active course. We have lots of different and interesting modules I want to tell you about, and I know I don't have that much time, but I just want to mention a couple of them. Physics Challenge is a third-year course. It's a compulsory course, and it's a lecture course without any lectures. So basically, it's a course where we set you real-world problems to solve in groups, and every week or every 2 weeks, you have solved your problems as best you can. Using the physics that we've taught you, but not in the way that you would expect. So you might have to use a bit of electromagnetism in a completely different context to answer the question. And there might be lots of ways to answer the question. It's really what being a physicist is about, though. Being a physicist is about this, getting a problem that you don't know how to solve and working it out. So anyway, you solve the problems in groups as best you can, and then you have a session with someone like me in a room. We have 2 teams on each side, and you battle for points. So each of you, each person in the group takes it in turn to go and present your solution on the whiteboard, and I'll be kind of marking the solution and marking, the presentation, and the other team have a chance to challenge for points if they think they've got a better solution. So it's super fun, and also a really great way to begin thinking about how you present your work. You don't want your first ever presentation to be in front of 500 people at a huge technical conference. So it's all about kind of building skills slowly and gradually, so that you're able to present your work confidently. Physics special topics. I just want to really briefly mention this. I know I don't have much time. It's a brilliant course, actually. It is, again, done in groups, and you have to write papers for your own journal. So we kind of recognise that, in physics, it's not clear to a lot of students how a physicist actually publishes their work. So our students have their own journal. It's called the Journal of Special Topics, and you go away, you write an article in a group about anything. It's not going to be cutting edge physics. We encourage kind of imagination. So there's often lots from Game of Thrones or Batman. We had one group who worked out how much hot air is produced by all the MPs in the House of Commons in a year. That kind of thing. You do a physics problem, you write it up into an article, it goes to the editors who are selected from the year group. They send it out for peer review, so your colleagues will review your article, send back their comments, and you iterate with them until you have the article published. So it's really just kind of getting you into what is it like to be a physicist, and how does our research career work. And you can find it, just Google Journal Special Topics, University of Leicester, you'll find some absolutely brilliant and hilarious articles, and they're all online. So in terms of what we teach, the right-hand side of the slide is showing you the physics degrees, the physics courses that are mandated by the Institute of Physics. So this is the core that everyone must study. And it's typical things you would expect: optics, thermodynamics, relativity, quantum physics. The left-hand side, just a few of the options that we give you, and you start choosing options from year 1 onwards. These ones on the left are higher level options. They're available in 3rd and 4th year. And so things like fractals and chaos theory, or spacecraft mission design, elementary particles. There's loads of options. Again, you can find all the details on our website showing you what we offered this year in terms of options. And this just gives you a chance to really delve deeply into a specific area that you discover interests you. And these are taught by experts. So the Institute of Physics that came and evaluated us last year, they gave us a 5-year accreditation, the highest accreditation you can get. And they were really impressed by the core that we teach. And the students just love the options available to them. Just gives them a chance to follow something that they find particularly interesting. So what is your life like? A typical week in the life of a first year? Well, in general, you'll have about 6 hours of lectures, a tutorial with your tutorial group, some feedback, so where you've maybe answered some questions and someone's going to help you go through the answers so you know where you went wrong and where you can improve. About 6 hours of lab. Lab takes place in the afternoons, Monday, Tuesday, Thursday, Friday. Not all of those sessions. You'll only do a couple of those sessions a week, and you won't do it every week. Wednesday afternoons is free for sport. So labs are in the afternoons generally, lectures are in the mornings. We try not to have too many 9 a.m. lectures, but here and there there'll be a 9 a.m. lecture. And then the workshops, this is in the open plan rooms where we go through problems in groups. So they'll give you somewhere around 20 hours of contact time. We expect around another 20 hours of private study, and that could be writing a lab report. It could be answering problems that we've set you. It could be doing your own reading or writing up your notes. So you're looking at around 40 hours a week in total. And in terms of assessment, this is quite unusual. In general, your assessment will be 70% exam, 30% coursework. And that's quite a high coursework component, 30% coursework for the modules. We do this because it helps you gain marks as you go along. So what we don't want is students walking into exams at the end of the year where the 100% of their year mark depends on those exams. They take place within a week. It's a high pressure environment. So we give you a chance to kind of gather marks as you go. It also helps students engage earlier on in the year with the material because they know they're picking up marks by handing in high quality work. So on average, 30% coursework, 70% exam. Our staff, as I said, we've got about 45 members of staff. On the right-hand side, this is just a few of us recently over the last year, maybe doing stuff for the Sky at Night. That's me pretending to be an astronaut on the BBC. At the bottom left, that's not my best photo. But we have staff that really are so passionate about what they do and world-leading experts that we do a lot of kind of television and media work, trying to encourage more people to think about physics and think about careers in physics. And so this is just a few kind of snapshots over the last year. As I said, we're a really supportive environment. I've talked a bit about tutorials, I've talked a bit about open door policy. We also have a student buddy system, so you can be assigned a buddy to kind of help you out as you join the department and kind of give you guidelines and tips and help and support. You can sign up for that as you arrive. As I mentioned, our course is all about teaching you how to be a physicist. So whether that's group research projects, we have group projects with industry that you can do. In third year, we have semester-long research projects. We have industrial partners that you can work with for a semester where they set you a problem and you and a group of people have to try and solve that problem and present your solution back to your industrial partner. You have an academic mentoring you, of course, as well. And there's some examples at the bottom there from Rolls-Royce to Airbus, Weatherford International, BGS. So there's lots of opportunities for you to get involved with industry and kind of really learn what it's like to be in the workplace and gain valuable employability skills that way too. And just going on employability, our graduates go off to do a world of different things. People often ask me, what can you do with a physics degree? The answer is almost anything, because you have incredible skills. You're numerate, highly numerate. You can write detailed reports. You have good computational skills, analytical skills. And our students just head off in all manner of directions, from spacecraft engineering to management, finance, of course, because the finance industry loves the numeracy skills that you have, the analytical skills that you have. So you can really, you shut no doors when you do a physics degree. You have so many options when you finish. I'm just going to show you a short clip, actually, of one of our recent graduates. And funnily enough, he and I did exactly the same thing when we graduated. So his story is my story. I'm going to play it for you now.
So I've got the NASA postdoctoral fellowship, and that'll see me positioned at the Jet Propulsion Laboratory in California, which is the site where NASA build a lot of their kind of Mars rovers and other kind of space missions. I was getting lectures from kind of scientists involved in active space missions, and that led to me being involved in a PhD where I was working on preparing for the European Space Agency's ExoMars rover. So I applied for my physics degree at the University of Leicester because of the focus on space here. So the involvement in a large number of different space missions from the lecturers and kind of hearing from them about the cutting edge research that's going on here. the work that I did during my PhD, kind of looking at how we explore Mars. I'm going to be transferring that with NASA to looking at kind of how we can adapt that to exploring Jupiter's moon Europa.
Brilliant. And actually, that's exactly what I did. I went and did a PhD at Leicester and then went to work for NASA for a number of years as a research scientist. So definitely a career path that's open to you if that takes your interest. So yeah, just to finish, the university actually is celebrating our centenary, 100 years of the University of Leicester. The celebrations are going to be over the next couple of years, actually. We really look forward to welcoming you. That's all I have to say for right now, but please feel free to write questions in the chat and I'd be delighted to answer them. So thank you.
Thanks for that, Susie. That was really great and really interesting to see all of the different elements of the course, not just the sort of, the basic bare bones of the modules and things like that. Someone's asked really quickly, I'm just going to cover this before I throw a question to you. Is it recorded? Yes, the session is recorded and it's going to be posted onto our YouTube site probably on Wednesday, so keep an eye out for that if you are interested in looking into that a bit more. But also just to highlight that we do have a lot of video content on our main event page, so you can check out all about the course and watch some videos as well on there if you are interested. One of the questions that we've had actually, Susie, is about the foundation year and what you can basically take afterwards. So, if you took the foundation year, would you be eligible for just the straight physics course, or can you do the physics combined with astrophysics or space science? And I think also whilst we're on that note, it might be good to know if you would actually be eligible for the embedded masters if you did the foundation, or whether that would rule you out because you did the foundation. So if you'd be able to cover that a bit, that would be great.
Yeah, absolutely. So you are eligible for any of the degree courses that we offer. So physics or physics with astro, physics with space science, 3-year, the 4-year, the year in industry, the year abroad. You're eligible for everything. You passed the entry requirements. So that's all good. You asked me something else. There was something else in there. Oh yeah. Also, so it's a STEM foundation year, and you'll specialise in the physics part. So you'll do various different aspects of STEM and maths, but enough to allow you, direct entry. So yeah, you're one of us at that point. You don't have to worry about being excluded from anything.
Perfect, thanks for that. I know there's a lot of stereotypes around foundation and whether it makes you eligible, so it's nice to know that you kind of have all your doors open. One of the things that I was thinking about whilst we were watching the presentation is about the embedded masters and what sort of benefits that have versus just the straight bachelor's, or maybe someone that decided to do a bachelor's and then did a separate master's afterwards. What sort of benefits would you say the embedded masters have?
Yeah, I mean, I think the Masters over the BSc, so from my perspective, I teach 2nd year, 3rd year, 4th year. 4th year is so exciting. 4th year is the year where you delve so deeply into a subject that you're interested in. You do 2 huge research projects in an area of your choice, working with an academic who's literally at the cutting edge of that discipline. You will do that in 3rd year too. You do a pair project in 3rd year, which is very similar. 4th year, you just get a bit more of that though. You do more options and you kind of delve a bit deeper. So I think 4th year is brilliant, and I would encourage everyone to think about 4th year. But as I said, you can do the 3rd year and then you can change to the 4th year if you want to. So we are flexible. The other option you can do is you can do a 3-year with us, and then you can do a 1-year master's. We offer a master's in space systems engineering, or you can go elsewhere and do a master's. That's great. The master's will be very focused. I guess the only thing to think about is you're going to have a shift at that point. So if you stay at Leicester, obviously you know your way around, but you'll be so comfortable here by the end of 3rd year. It wouldn't surprise me if you just choose to stay for the 4th year rather than switching to do a 1-year master's elsewhere. But it's definitely an option for you.
Perfect, thank you for that. We've had another question pop through, and to be fair, I also struggle with this sometimes. What is the difference between astrophysics course and the space science course? So obviously the combinations, what would you say, is the main difference between the modules and what you learn? So you touched on it in the presentation, but what would you say how that translates in terms of the course and what you study?
Sure. Well, actually, you choose a couple of options in 1st year, for example, and you can choose the space science and the astrophysics options if you want to. You can do both, or then we have other options like modern physics, etc. So you don't even have to do one or the other. You can actually do both of those topics all the way through. So it really just comes down to the options that you choose. as I said, space science, that's what I teach. This is all about, how do we send something to the planet Mercury? Why do we want to go? What will we learn? What are the questions we need to answer? How do you design a mission? All those kind of questions, not just Mercury, that's just what I love, but other planets are optional. And then the astrophysics is kind of the broader environment of space. But yeah, we don't make you choose space and then exclude you from doing astro. You can actually do both as you go through the degree, and then choose if you've done both all the way through, you can kind of choose the title that you'll graduate with at the end.
Yeah, and I think, as you mentioned as well throughout, as you start studying, you get a feel for what each thing is as well, and what you want to do. So you're not necessarily like signed up to astrophysics and then you want to do space a bit later. So it gives you that sort of room to move.
And actually, if you do a massive mishmash all the way through, then you graduate with a physics degree with anything. So you can totally do that. You can totally just change your mind in every year if you want to.
Perfect. On the note of modules, I thought it'd be nice to sort of touch on the balance of core versus optional modules, because obviously they'll differ year on year, because you need to have like a foundation in certain knowledges and things like that. So would you be able to sort of explain a little bit more about that balance of modules that you have to take versus ones that you have options on?
Yeah, certainly. So you'll choose a couple of options in first year. First year it will be a lot of maths, because it's our language. We have to teach you a lot of maths. I teach maths. I love it. So there'll be a lot of maths. There'll be a couple of core courses that you have to take each semester, and then you'll have an option course to take. As you go through, the balance will shift more towards options and away from the core. So as you said very correctly, you can't understand my subject, space plasma physics, if you don't know plasma physics and electromagnetism and mathematics. And so the core is there to build the knowledge to allow you to then choose those higher level option courses later on. As you head towards fourth year, and there's very few compulsory modules, almost all options. Third year, again, very few compulsory modules. I think maybe a couple per semester, that's it. And the rest are all options and research projects.
Perfect, thank you. I thought we'd round off with just maybe some top tips that you might have for students that are looking to apply to physics, and maybe what you're looking for in a personal statement or in an applicant that kind of makes them stand out. So I thought I'd leave that with you, and then if you wanted to round off the session as well, that would be really great, because we've not had any other questions.
Okay, great. Yeah, what am I looking for? Yeah, this is really interesting. Having just been through the end of a cycle and starting a new one with admissions. Yeah, I mean, I'm not looking for people to have done a ton of things like I went to CERN and I went to NASA and I like all this sort of, these trips are amazing. What I really want is you to be able to share with me what you are interested in. Like, why do you want to do physics? And that could be that I read a book by this person and it really inspired me to think more about this topic. Or it could be I did a little project in my A-levels and I love the subject, or, I love maths and I love applied maths, and whatever it is that makes you want to study physics, I want to hear about it. And I want that personal statement to be able to tell me that story. What I would say about personal statements is that it breaks my heart when I see like personal statement version 12. I know that it's, super stressful for you to write, and has to be good English, it has to be grammatically correct. No, I don't want spelling mistakes. But if you can just try and get across why you want to do the subject, maybe what topics interest you specifically, how you got interested, and the kind of basics, that's really what I want to hear. And just, write it as sort of honestly as you can, and reflect yourself, and that's it really. So don't worry about, I haven't done a load of work experience and I haven't been to CERN, it's fine. It's not all about that. It's about showing why you want to do the subject. So so good luck with your applications. I hope that everything goes smoothly. If you have questions for me, my name is Susie Imber. You can find my details on the university website. Just get in touch, reach out to me. I'm happy to answer any questions about applications or about the course. Again, things will come up in the next day that you forgot to ask today, and just reach out to me if you need me. Good luck with everything. Good luck with your new school year, and I look forward to maybe welcoming some of you to the university next year. All right. Thank you very much, everybody.